Good morning all. 1 second, please. Good morning, everyone. Guys, today we are going to discuss very important topic, so which is economic. Okay, so let me share. Yeah, and I request all of you, so please mute yourself. Okay, right. Guys, is the screen visible? Screen visible on the andarki?
Yes, sir. Visible, sir.
Right. Okay. Okay, so economic span of a bridge. Okay, right. So what do you mean economic span? So I think in this bridge terminology, so we have clearly explained about what do you mean economic span. So the cost of superstructure is equal to cost of substructure. So is nothing but economical span. Okay. So ఎప్పుడైతే బ్రిడ్జ్ యొక్క సూపర్స్ట్రక్చర్ యొక్క కాస్ట్ సబ్స్ట్రక్చర్ యొక్క కాస్ట్ తో ఈక్వల్ గా ఉంటుందో, so that cost is going to, that span is going to be called as economical span. Okay. Cost of superstructure is equal to cost of substructure. Understand? So this is superstructure and this is substructure. Then that span is going to be called as an economical span. So today we are going to discuss how to achieve the cost of superstructure equal to cost of substructure. So which is going to be called as an economical span. Okay, that we are going to discuss. So basically the economic span of the bridge is one, which is going to reduce the overall cost. So why this economical span is required? So to reduce the overall cost of a bridge. Okay. Understand? To reduce the overall cost of the bridge. So overall cost of the bridge is going to be depends on few parameters. Okay. So they are going to depend on few parameters. In the parameters, so let's discuss one by one. So first parameter is based on the cost of material, isn't it? So if the cost of materials are more, automatically the total bridge cost will be more. Cost of material and its nature. And then, right? And the next one, it depends on availability of skilled labor. Availability of skilled labor. Okay. And the next one, it is based on the span length. If the span length is more, okay, in between two piers, okay, this is called a span. If the span length is more, automatically the overall cost of the bridge also will become more, isn't it? That's why this span length also will be depend to reduce the overall cost of the bridge. And next one, nature of stream. సార్ చెప్దాము. సో ఇఫ్ సార్ యాడ్ చేయమంటే చేద్దాం. Nature of stream to be bridged. Okay, nature of stream to be bridged. And so what type of stream it is? So definitely if the stream is very wide, automatically the span of the bridge also will become more. The length of the bridge also will become more. That's why the nature of stream also will depends on the overall cost of the bridge. Okay. And next one, climate. Climate and other conditions. Okay, climate and other conditions are also is going to reflect the overall cost of the bridge. Understand? So these are the major dependence on the overall cost of the bridge. So apart from that, so basically these are going to be in any hand of an engineer? ఇవన్నీ మనం ఏమైనా చేంజ్ చేయగలమా? చెప్పండి. Cost of materials, availability of skilled labor, span length. Are we can able to change all these things to reduce the cost of the bridge? No. So we can't change them, right? So that is the reason why it is not in the hands of any engineer to bring down the cost of these things. So వీటిని ఏమంటామంటే living index అంటారు. Living index or price of materials. Understand? So definitely this living index or nothing but price of materials, one can't able to change them. So like what are the materials? Nothing but cement avvachu, steel avvachu, timber avvachu. Okay, all these are the materials, we can't able to change them. So what we can do, we can only able to reduce the cost of the bridge by involving economical design. Understand? Only an engineer can do that. Okay, so we can't change all these things to reduce the cost of the bridge. So these, why? Because they are not constant, they are variables. So but how can we reduce the overall cost of the bridge? We can only reduce only based on the economical design. Okay, so we can bring down, that engineer can bring down the cost of bridge only by having the economic design. Okay, by doing economical design only, one can able to reduce the overall cost of the bridge. How to do this economical design? That is what about economical span of the bridge. Okay, we can't change all this. If we can able to change, definitely this will reflect the cost of the bridge. Okay, as మనం change చేయలేం కాబట్టి, so definitely an engineer can able to bring down the cost of the bridge only by having an economical design. Okay, so that is going to be considered as only variables items. So the cost of superstructure is going to increase, and then the substructure is going to be decreased within the increase of the span length. Okay, so let me discuss that. So what happens, Amma? Cost of superstructure, cost of superstructure increases. When it is going to increase? Substructure decreases. Cost of superstructure increases and the substructure decreases within the increase in the span length. And then clear? Cost of superstructure increases and that the substructure decreases within the increase in the span length. So the most economical span length is that which is going to satisfy the cost of superstructure is equal to the cost of substructure. This we are going to achieve by doing one kind of derivation. Right? Guys, understand? So cost of superstructure increases and the substructure decreases within the increase in the span length. Okay, so if you take any bridge, which will have a foundations here. Okay, so the bridges which is resting on this, so this comes under the substructure. This will comes under the superstructure. So ipudu whatever the, why? Because this is the span. Okay, so the total cost of the superstructure is going to equal to the cost of substructure. That is going to be an economical design. So usually what happens, the usual variable item, the cost of superstructure and the cost of substructure decreases within the increase in the span length. Kada span పెరిగినప్పుడు ఏమవుతుంది? Only if the span is increasing, cost of superstructure will increase, but cost of substructure will get decreased. Kada? So because if you see the same bridge with the same pillars, okay, I can have even more span. Even I can have a very big span. Okay, here let us say the span length is 100 meters. Here the span length is 50 meters. Okay, see the number of piers are 2, but the span is increasing. So when the span increases, which cost will increase? When the span increases, which cost will increase, Amma? Substructure, superstructure. When the span length increases, which structure cost will increase? Guys, please respond.
Superstructure.
Superstructure. That is what the statement reflects. Cost of superstructure increases and the substructure decreases within increase in the span length. Understand? So by considering these parameters, we are going to achieve the cost of superstructure is equal to cost of substructure as an economical design. As an economical design. Okay. How to do that? How to achieve this cost of superstructure is equal to cost of substructure anedi? We are going to do that derivation. Okay, guys? Clear? Ikkada varaku andarku ardhamainda? What is this economical span? Why we have to go with economical design? How can we reduce the cost of overall cost of the bridge anedi meeku concept ardhamainda ardham avvaledu cheppandi. Then I will start the derivation. Guys, please respond. Clear? Ikkada varaku? Students, please respond. ఏమా రెస్పాండ్ అవ్వట్లేదు. క్లియరా? హలో, గైస్ కాన్సెప్ట్ అర్థమైందా? వాట్ డు యు మీన్ ఎకనామికల్ స్పాన్? Okay, see, for any derivation there will be a few assumptions, right? So let me first derive what are the assumptions for the economical span of the bridge. Okay, assumption. The first assumption, these are very important. So the bridge has equal span lengths undali. Okay, the first assumption is that your bridge should have an equal span length. Nothing but, so let us consider these are the pillars, these are the piers. Okay, so these are the spans. So whatever the span length, all these span lengths L1, L2, L3, make sure that L1 equal to L2 equal to L3. All spans should be same. All spans should have a same length. Okay, so that is the first assumption. Okay, next one, the cost of supporting system. What do you mean supporting system? Because this is superstructure and this is substructure. Okay, so what do you mean supporting system? This substructure is a supporting system. Clear? So the cost of supporting system of superstructure varies as the square of the span length. And the cost of supporting system for the superstructure is varying as the square of the span length. And L square outundanta. Okay, square of the span length. So this is the span length. L all are same. So by that I can consider it as L. L1 equal to L2 equal to L3. So the span length is nothing but L. So the assumption is that the cost of supporting system of superstructure varies as the square of the span length. Nothing but L square ani assumption తీసుకున్నారు. Okay, next one. Why? Because your span length is not constant. Your span length is a variable. It all depends on your supporting system. Okay, so that is it. Because if your supporting systems are more, automatically the number of spans may increase, the span length may increase. Understand? So by that, this constant supporting system is a variable. It is not constant. It is a variable parameter. Understand? Right. What is the next one? Next assumption is cost of flooring. What do you mean flooring? Slab or deck. Cost of flooring and parapets. Parapets ante entama? Whatever the crash barrier we are constructing over the deck. So nothing but crash barrier. Okay. So this is called crash barrier. Okay. So this always we construct above the slab, above the deck. Understand? So cost of flooring on or parapets also variable directly as the span. It is also a variable. Why? Because this cost of flooring or cost of parapets, flooring, everything, it all depends on the span. If the span length increases, the length of the parapet wall, the length of the flooring, nothing but length of the deck also will increase. Understand? So by that, cost of supporting system, it always depends on the span length because there is a variable. So cost of flooring or cost of parapet also is variable. Okay, these two are the variable parameters. Okay. So these are the assumptions. And the next one, cost of one pier and its foundation is constant. Avuna? Because pier, this is what the pier and this is what the foundation, isn't it? So the cost of pier and the cost of foundation is constant. It won't depend on the span, isn't it? Yes or no? Your cost of pier and foundation, will it depends on the span? Chapali, will it depends on the span? No. So cost of one pier and its foundation is constant. Okay, that is also one of the important assumption we have to draw for calculating the economical span of the bridge. And the last one, cost of abutment and its foundation is also constant, isn't it? Why? Because for any bridge, there will be only two abutments. Even though if it is a 10 span bridge or 5 span bridge or 1 span bridge, there will be only two abutments. So by that, the cost of abutments and its foundation is also constant. Okay, these are the important assumptions which we have to draw for calculating the economical span of the bridge. So please try to revise again. The bridge should have an equal spans. The cost of supporting system for the superstructure should be square of the span length, which is a variable parameter. Cost of flooring and parapets is a variable parameter. Why? Because cost of deck and parapet wall or retaining wall, or crash barrier, it depends on the span. Kabatti, it is a variable parameter. Cost of one pier and its foundation is a constant parameter. Cost of abutment and foundation is a constant parameter. Okay, so these are the assumptions, okay, which we have gone through. So now let's do the derivation. Keep the heading, calculation for effective economic span. Okay, so please try to focus on the derivation. It is very easy. Okay, so please try to note down. Let first write down the given data or the parameters. First L is equal to total length of the bridge. Okay, in the right hand side, let me draw one diagram for a bridge. Okay, so by that you all can able to understand it clearly. Okay, so what are these two? These two are called abutments. Okay, and there will be piers. Okay, for this there will be a foundation. For this also there will be a foundation. Okay, right. So on the top of this, there will be one span. This is called span, center to center distance of the bridge. Okay, so let me draw with the blue color. By that you can able to differentiate what is superstructure and what is substructure. Okay, so this is called slab. Over the slab, what will be there? You will have a parapet wall, isn't it? Okay, so let me draw with another color. This is the parapet wall or crash barrier under. Okay. Right. So this is what the crash barrier. Okay, right. And there will be an approach slab. Kada? So there will be an approach slab. How many approach slabs will be there? There will be 2 approach slabs. One will be on the right hand side and the other will be on the left hand side. Okay. So this is called approach slab. Okay. So let me indicate all. This is abutment 1, abutment 2. So these are called piers. Okay. And this is called span L. Overall length of the bridge ni capital L under. Okay. This is called capital L. Okay, guys. So now let's write down the parameters. First, L is equal to total length of the bridge. This is called capital L. And next, small L is equal to span length. Okay, this is called span length. And center to center distance between 2 supports is called span length. Okay. Next, N. N is equal to nothing but total number of spans. Total number of spans. For this example, how many spans are there? How to calculate total number of spans? How to calculate total number of spans? Chappalamma, how to calculate total number of spans? Total length of the bridge by each span length will give total number of spans, isn't it? So total length of the bridge by each span length will give number of spans. How many spans we have for this example, for this bridge? Any spans unnai? Guys, please respond. Chappali, how many spans we have for this bridge? Hello. In capital P. What do you mean capital P? Cost of one pier with its foundation. Because foundation will be attached to the pier. So that's why we have to consider the cost of pier along with the foundation as a overall cost. Okay. Next, A1. A1 stands for cost of abutment. So cost of one abutment and its foundation. Okay, right. So please consider this as an A ante. Okay, A1, A2 kaadu, idi mottam A. A ga consider chain. Okay. Okay. A ante abutments. So here I am considering A1 as a cost of one abutment and its foundation. How many abutments we have? We have 2. Okay. So cost of one pier with its foundation. How many piers we have? We have 2. Okay, like that. And next one, A2. A2 is nothing but cost of one approach slab. How many approach slabs we have? We have 2 approach slabs. Okay. So this is another A. Andike we are considering abutment as A1 and approach slab as A2. Okay. Cost of one approach slab is A2. Okay. And finally, capital T. Capital T is nothing but total bridge cost. Understand, guys? So this is the total bridge cost. So these are the important things we have to know before starting the derivation. Total length of the bridge, span length, number of spans, cost of one pier with its foundation, cost of one abutment with its foundation, cost of one approach slab, and total bridge cost. So finally, my bridge cost, this total bridge cost is to satisfy cost of superstructure equal to cost of substructure ga satisfy avvali. Then only your span is going to become an economical span for the bridge. Clear? Right. So now let's start the derivation. Okay. So derivation clear ga chudamma. According to second and third assumption. What is your second assumption, Amma? Your second assumption is that cost of supporting system of superstructure varies as square of the span length, Annam. That is what the second assumption. And what is the third assumption? Cost of flooring and parapet walls varies directly as the span. So this is the third assumption. Understand? So based on these two assumptions, let's write down cost of one span of superstructure, because bridges will have n number of spans. So first, let's take as a cost of one span of the superstructure. Why? Because our first assumption is that bridge should have an equal span length. Annam kabatti, if we are going to satisfy cost of one span, which will be satisfied for the other spans also. Okay. So by that, cost of one span of superstructure is equal to, based on the assumption. Eight assumptions cheppandi. One assumption is square of the span length, and the next assumption is cost of flooring and parapets are variables. Kada? So cost of one span of the superstructure is equal to A1 L square plus A2 L under. What do you mean that? Why? Because A1 is equal to constant. In your assumption, we have drawn two constants. A1. A2 is also a constant. What do you mean A1? A1 is nothing but second assumption. Cost of supporting system varies as the square of the span length. That is what the A1 constant. What is A2 constant? Cost of flooring and parapets also varies based on the span. That's why A1, A2 constants man తీసుకుంటాం. L square, that is what the second assumption is talking about. Okay, square of the span length annar kabatti A1 L square plus A2 L. Understand? So these two are nothing but assumptions of the second and third points. Okay, so here these two are constants. A1, A2 are constants. Okay, now there are n minus 1 number of piers and 2 abutments. Isn't it? Isn't it? How many number of piers we have? How many number of piers we have? What do you mean n? N and entama? N is nothing but total number of spans. Okay. How many piers you will have? If your bridge is having 2 spans, 1, 2. Okay. Right? How many piers you will have? Because this is an abutment. This is an
Single
abutment.
pier.
This is how pier. If you are having 2 spans, how many piers will have?
Sir, only one, sir.
1 pier. That is what. So there are n minus 1 number of piers. Okay. Why? Because n is nothing but number of spans kabatti. N minus 1 will use the number of piers, and there will be only 2 abutments. Okay. Right. Now the total cost of the bridge. So this is what we have to calculate finally. Total cost of the bridge is equal to ento cheppandi. Total cost of the bridge ఏమవుతుంది? So నేను రాస్తాను అవి ఏంటో చూడండి. Total cost of the bridge is equal to cost of supporting system of superstructure. అవునా? Superstructure యొక్క cost of supporting system of superstructure అంటే substructure ఉన్న total cost plus cost of 2 abutments, right? Plus cost of n minus 1 piers, because we don't know how many number of piers we'll have for a bridge, because it all depends on the number of spans. Anduvalla cost of n minus 1 piers antunam, but we know how many number of abutments will be there. For any bridge there will be only 2 abutments. That's why cost of 2 abutments plus cost of n minus 1 piers plus how many approaches we have? How many approaches we have? 2 approaches. So cost of 2 approaches plus ఇంకేం యాడ్ అవుతాయేమో total cost of the bridge లో? Railing and parapets. Understand? So this all will give the total cost of the bridge. Cost of supporting system of superstructure. Nothing but what? Cost of supporting system of superstructure and enti. Substructure and ardham. Okay. Plus cost of 2 abutments plus cost of n-1 piers. Okay. Plus cost of 2 approaches plus railing and parapets. Okay. So this is what the total cost of the bridge. Okay. Now let's start all these with a clear derivation. Total cost of the bridge is equal to nothing but T is equal to N of A1L square plus A2L. What is this A1L square plus A2L? This is nothing but cost of one span of superstructure. That is what we have written in the previous. So how many spans we have? We have n number of spans kabatti n to multiply chestam. N of A1L square plus A2L. Clear? Plus 2A1. What do you mean 2A1? 2 abutments ani. Plus 2A2. What do you mean 2A2? 2 approach slabs ani. Plus n-1 P. What do you mean n-1 P? Number of piers. Clear? First you have to understand this. Then only you can able to understand the next things. Clear? N of A1 L square plus A2L is nothing but cost of one span of superstructure. 2A1 is nothing but number of abutments. 2A2 is nothing but number of approach slabs. N-1 into P is nothing but number of piers. Okay. Now, what do you mean N? N is nothing but capital L by small l. We'll use the number of spans. Now replace N is equal to capital L by small l to replace change. Equation T is equal to capital L by small l of A1L square plus A2L plus L by L by small l minus 1 into P plus 2A1 plus 2A2. Yes, clear? Just I am replacing your number of spans into L by small l. Okay. Now L A1 small l. Ante kada idi cancel ayipotundi. Plus A2L plus PL by small l minus P plus 2A1 plus 2A2. Correct, Anama? Okay, this is what the final. Now, therefore, do the differentiation. dt by dl is equal to, so do this T equation differentiate with respect to L. Differentiate this total cost of the bridge equation with respect to span. L and small L nothing but span. Equation A1L plus this all parameters will become 0 minus PL by L square. Isn't it? Antena? Okay. So this is what the final equation which we get. Now to get for T to be minimum. What do you mean T minimum? We'll use the less cost of the bridge. Okay. We'll use the minimum cost of the bridge. For T to be minimum, what I have to do? I have to do T by DL is equal to 0 cheyali. Okay. If I do this 0, then you will get the minimum cost of the bridge. So now equate these two equal to 0. What you will get? Side lo chudandi. dt by dl is equal to 0 cheyandi. A1L minus PL by L square is equal to 0. A1L equal to PL by L square. Yes. So now 1L and 1L cancel. A1 is equal to P by, sorry, differentiate change number. Sorry, capital L kada. Sorry, A1 L capital L. Sorry. Please small change. A1 capital L minus PL by L square. Okay. So ఇది capital L అమ్మా ఇది. Okay. One second. Let me erase this. Yeah. Write down the equation. A1 capital L minus P capital L by L square is equal to 0. A1 capital L is equal to PL by L square. L will be cancelled. A1 is equal to P by L square. P is equal to A1 L square. So nothing but economic span is equal to L is equal to root of P by A1. Okay, P by A1. So ఇక్కడ మీరు ఈ ఈక్వేషన్ అబ్జర్వ్ చేయండి. What is this equation? What is this equation? P is equal to A1 L square అంట. అంటే కాస్ట్ ఆఫ్ 1 peer is equal to cost of superstructure with respect to constant. అంటే now economical span ఏమవుతుంది? Economical span is equal to nothing but 1 span is equal to root of P by A1. Root of P by A1. So from this, what I can draw? I can draw that cost of supporting system of 1 span is equal to cost of 1 peer. And then cost of 1 peer is nothing but what? P. Cost of supporting system of 1 span is nothing but what? A1 L square. So when these two are equal, finally what I can able to drag from this, cost of substructure is equal to cost of superstructure. Why? Because peer is a substructure, supporting system of 1 span is nothing but superstructure. So finally from this equation I can able to understand that cost of substructure is equal to cost of superstructure. Understand? So this is what the economical design of the bridge. So from this, whenever you do design, make sure that, okay, so 1 peer cost అనేది supporting system of 1 span ki equal అవ్వాలి. Okay, supporting system of superstructure ki equal అవ్వాలి. Okay, understand? So this is what about